Welcome my dear students of class 10. Today we will start with our next periodic property, electronegativity. Now what is this electronegativity? It is the tendency of an atom in a molecule to attract the shared pair of electrons towards itself. So, the tendency of an atom in a molecule to attract the shared pair of electrons towards itself. Let us take one example of a covalent compound XY. So one covalent bond means what? It means two electrons. Now suppose if I say that the electronegativity of Y is more than that of X, what does it signify? It signifies that this Y has a greater tendency to pull this electron or attract the shared pair of electron towards itself. Now suppose if Y is pulling this shared pair of electrons towards itself, Y will become delta minus and X will become delta plus. Electronegativity depends on two factors. The first one is atomic size and the second one is nuclear charge. See, this electronegativity deals with attraction. So, greater the attraction, greater will be electronegativity. Now, atomic radius, when atomic radius increases, then attraction will be less, hence electronegativity will be less. So, electronegativity and atomic radius, they are again inversely proportional to each other. En stands for electronegativity. Now, nuclear charge, greater the value of nuclear charge, more will be the attraction and hence more will be the electronegativity. So, electronegativity and nuclear charge, they are directly proportional to each other. Now let us see the trends in electronegativity. Across a period from left to right, electronegativity increases. And down the group from top to bottom, electronegativity decreases. Now when we are traveling from left to right across a period, atomic radius decreases, hence electronegativity increases. At the same time, across a period, nuclear charge also increases. So this is also favoring the increasing electronegativity. Now down the group, from top to bottom, atomic radius increases. Hence, electronegativity will decrease. Here also we have the same competition between R and Z. And always it is R who wins. So here R will play the key role in determining the trends in electronegativity. I think now try to recall that ionization potential, electron affinity, they also increases across the period from left to right, and ionization potential, electron affinity, they decreases from top to bottom down a group. So electron affinity, ionization potential, electronegativity, they follow the same trends across a period as well as down a group. So once again, I am repeating, electronegativity, ionization potential, electron affinity, they increase across a period from left to right. While traveling from top to bottom down a group, electronegativity, electron affinity and ionization potential decrease. See, electronegativity refers to attraction. And what about electron affinity? The word affinity means love. See, love, attraction, these words, they have the same vibes. So now let us discuss the difference between electronegativity and electron affinity. Now this electronegativity refers to an atom in a molecule. Atom in a molecule. What about electron affinity? Electron affinity deals with an isolated atom. So here we have the concept of shared pair. But here there is no question of sharing because electron affinity deals with isolated atom. Now this electronegativity is a tendency of an atom to hold its own electron, whereas in case of electron affinity, what happens? There we are adding one external electron. So here to hold its own electron pair. Here we have to add one electron. Now, electronegativity is a dimensionless quantity, whereas electron affinity is energy released. So this is dimensionless. And this electroaffinity will have the dimension of energy. Electronegativity is measured in different scales. The most widely accepted scale of electronegativity is Pauling scale. Which element in the periodic table has maximum value of electronegativity? It is none other than fluorine. And the value of electronegativity of fluorine according to Pauling scale is 4.0. Now if you were asked that which group in the periodic table has maximum value of electronegativity, it is group 17. So group 17 is a group in periodic table which has maximum value of electronegativity. Now we will discuss about metallic and non-metallic character. Now what is a metal? A metal is an element which has a tendency to lose its valence electron, thus leading to the formation of a cation. That means if an element can easily lose electron, which electron? Valence electron, to form a cation, then its metallic character will be more. So now let us discuss the factors affecting this metallic character. First one is atomic radius. How atomic radius affects a metallic character? Now, if atomic radius is more, that means distance is more. Distance more means effective attraction is less. So, it is easy for the element to lose electron and become a cation. That means metallic character is directly proportional to atomic radius. Now the second factor is nuclear charge. Nuclear charge more means more attraction. More attraction means it is difficult for an atom to lose its valence electron. So nuclear charge and metallic character, they are inversely proportional to each other. Now we will discuss the trend in metallic character. Across a period from left to right, metallic character decreases, and down a group from top to bottom, metallic character increases. What is the reason? When we proceed from left to right across a period, R, that is atomic radius, decreases. And just now we have studied that R and metallic character, they are directly proportional to each other. So, across a period from left to right, since atomic radius decreases, so metallic character also decreases. Now, down a group from top to bottom, R increases, that is atomic radius increases, so metallic character also increases. Always remember that R is playing the predominating factor. Now, if metallic character decreases in this way, then what about non-metallic character? Non-metallic character will follow the reverse trend. That is, when we travel from left to right across a period, non-metallic character increases. What about from top to bottom down a group? Top to bottom down a group, non-metallic character will decrease.